Good afternoon, everyone. I cannot say now good morning. By the way, this is Asmaa Ibrahim. I work for Vodafone group. Sometimes we call it TSSE, sometimes we call it VIS, and so on, whatever. I'm working as a solution architect, mainly in machine learning and AI. To be honest, I don't like to represent my company today. I wanted to represent Docker community as a co-founder of Docker Meetup, and I see a lot of people coming today from my meetup. I'm recently co-founder of Women in Machine Learning Data Science Meetup. Recently, alhamdulillah, I became the first woman to become Google Developer Expert in ZAMEA. So I can attend all Google conference for free, even I can give speech in any event related to Google, alhamdulillah. Today I will talk about how Docker support machine learning model deployment. We have a customer, we have a data scientist, and the data scientist came to the customer, come on, I have finished the machine learning model. Then the customer say, okay, come on, how I can take this model? Should I take it in my bag? Something like this? No. Today I will talk about how Docker support the machine learning model productionization and operationalization, yeah. So, to talk and to achieve this, I wanted to define some key terminologies like definition of machine learning. Come on, no one here, I see all people now heard about the keyword machine learning. It's like a buzzword, it's like a dream. During my work, every day, since we have started the machine learning team since around 2 years, when the customer came to us, they didn't understand what is machine learning actually. Just, I wanted to apply machine learning. Okay, tell us, what's the volume of the data that you have? And they said, one Excel sheet, around 100 row. Really, do you want to apply machine learning with this data amount? Let's see. After talking about the machine learning definition, the difference between traditional software development and machine learning software development, you will see the difference definitely. I will go through containerization paradigm, and thank you for Dr. Ahmed, he already did a deep walkthrough in this one. Then I will talk about Kubernetes as a solution architect. Sorry, I will give you some high-level view about different architectural paradigm to solve some challenges related to machine learning deployment, models deployment. And as I mentioned by Andrew before, thank you for saying this, we're here not to answer your question actually. Let's interact and have a conversation. Follow me in Docker Meetup and all of this stuff so we can have more rich conversation, better than answering your questions. First terminology is machine learning. If you do any simple research now on the internet about machine learning keyword, you will find the definition of machine learning. It's one of the key arms of artificial intelligence. So it gives the system capability to learn, to understand from data or something like this without being explicitly programmed. Okay, more detail about machine learning programming versus the traditional programming. In the traditional programming, you have a problem. So you ask, for example, software engineer and tell him or her, can you find a solution, like an algorithm for this problem? Then you end up with a software developer, or we say, sorry, developer, not software developer, nothing called software developer, by the way. We have a developer change or transform the algorithm to be a code, then you end up with having algorithm. And this algorithm has an input and has a result. Okay, machine learning is not the case. In machine learning, we are data-driven. We have a data, we try to figure out how to gain a value from this data. We need to articulate a problem on top of this data. And to have data, we need to have some specs to say this data is ready to build a machine learning algorithm on top of it. So after doing what is called data collection, data preparation, you give this data to the data scientist to start to select the best machine learning algorithm, according definitely to the business problem. Yeah, based on what the data scientist can say this yeah, this algorithm is better than this algorithm. Actually, it's based on the business success criteria. At the beginning, you should build what is called success criteria with the business. This one is very heavy to me. Okay, by the way, sorry. So you need to talk with the business to have what's called to have a success criteria. So according to this, you can validate the machine learning algorithm. You will end up having what's called machine learning model, has an input, and end up with results. Here, what's called machine learning pipeline. If you do any quick research now at internet, you will find this pipeline become standard one. We have in the first phase what is called design phase, design thinking phase. In this phase, all of the teams sit together to understand the data, do assessment of the current infrastructure, all of this stuff, and define the business problem. And sometimes in this phase, we end up with having POC on top of the data, mapping it with the business requirement. Moving to the next phase, yeah, we have defined the problem. We have an enough sample of the data. Let's do next step, which is called data understanding, data exploratory. And this phase, we do what's called data cleansing, normalization, transformation, all of this stuff coming as a part from data engineering. And definitely we need to figure out how we can do data ingestion, how you will move the data from the customer environment to the environment of the development. It's not an easy, actually, because when we talk about the data, we talk about the privacy, we talk about the security constraint, we talk about the limitation of the tool. Is it related to batch processing or stream processing? And every one of them has a different way of moving the data to the development environment. The next phase will be the role or data scientist. The data scientists start to do what is called modeling. I mean here by modeling, model development, model training, validation, testing, all of this stuff. Once we have a model, here start the pain. And when I say the pain from my organization perspective. When we start to build the first use case using machine learning, we stuck in the deployment phase. Because when we did an assessment to the customer environment, they told us, come on, the security will not give an approval to push or pull any data, even or code. To be honest, we have done some workaround. We have sent the data via an email, and we have sent the code via email. And we have generated automated way to listen to the email and try to grab the code or whatever the data. Yeah, it's funny, but this is the case. Actually, when we talk about machine learning productionization. Yeah, I'm sure that you have seen this figure before because this one is related to software-defined software development life cycle. Yes, but in machine learning development, we have some tweaks related to the traditional software development. Why? Because we are data-driven. Data-driven, we start, as I mentioned before, in the machine learning pipeline with the design phase, design thinking phase. Then we have data acquisition, then modeling, and definitely in the middle we have optimization. Yeah, machine learning development. Machine learning development is like a baby. It's not a traditional software you will build today and the developer will give it to the business and the story is ended. No. Actually, the journey started when you deploy the model. When you have the model live in a production environment, you need to monitor. First use case, we have stayed around 7 months monitoring the model and see if the results are coming from the model are accurate or not. Is it achieving the business value or not? So we have optimization, deployment, operationalization, monitoring, analyzing and reviewing the results, and might end up with optimization, and again, it's an iterative approach. How many times you will do this iteration, you cannot imagine it. It depends on the complex level of the use case itself. So, as Andrew mentioned before, and I'd like to thank him again for saying this, it's about people. You cannot achieve all of this without people. When we talk about machine learning development, we talk about key personas. So let's scatter them in 3 categories. We have development, we have IT operation, and we have definitely the business, the people who will give us the money. Without them, we cannot do anything. So starting with the business, you can say this is a mature view of key personas in machine learning-based project, because we cannot, and sometimes we didn't start with all of these personas. At least in the business side, we need to have business owner. Sometimes who plays this role is called product owner, and definitely we need business analyst, but not at the beginning. You can start with only having the business owner. Then we have the development. In the development, we have the data engineer, who is responsible for data engineering. I mean here, data transformation, normalization, cleansing, data ingestion mechanism, all of this stuff coming from data engineer responsibility. Next persona, and this is the key persona here in all of these personas, is a data scientist, the one who is responsible for modeling, building the model, selecting the algorithm, all of this stuff. And it depends on categories of the machine learning algorithm. You will figure out who will be a data scientist or a good data scientist for this use case from your team. Sometimes we need data scientist who is expert in statistics or applying some supervised machine learning or unsupervised or clustering. It depends. You need to figure out this one very carefully. From the IT operation, and this is a key box here, which is related to my presentation today, is IT operation. Here I'm talking about solution architect, someone like me, DevOps engineer, and test engineer. And to be honest, not all use cases we start with having solution architect. Yeah, to be honest. Yeah, it's better to have a solution architect from the beginning, but not all the cases that we have this person. We have, because this person is responsible for doing what's called assessment of the infrastructure with the customer at the beginning to define the constraints related to the infrastructure environment when we talk about model deployment. And we have DevOps engineer, the one he or she is responsible for packaging the model, how we will give the model or push the model to the production. Should we put it in like a bag or something like this? Definitely no. We need to package this model, what's called, as mentioned by Dr. Ahmed, put it in a Docker image and start to run an instance from this Docker image, what's called container. So we do a containerization of the model, of the trained model to be more accurate. And definitely we need a test engineer who is responsible to do the testing with the data scientist, because the data scientists do a testing too besides the testing engineer. These are the key personas, because it might, some cases more than this. If we do what is called intersection between the personas and the process, I mean the machine learning pipeline by process keyword, according to Gartner, you will see that there are some key activities have been done in every phase. For example, for problem understanding, we have determination of objectives, defining the success criteria, assessing the constraints, doing what is called data assessment. All of this coming in the first phase. And you will see that the data scientists and business are heavy involved in this phase. And you will find IT operation, the role of solution architect will come in this one. Then you have the data understanding, and here you will find the data engineer role is very light in this one, is very clear, sorry, in this one. Besides the business, besides the DevOps engineer, all of this. And so on. I will not go deeply in this one. You can see this slide in the presentation later to be mapped with the time. I'm not sure if you can see, you can see the color. As I mentioned before, I give a focus to the deployment and operationalization of the machine learning model. Yeah, another colorful slide. Here I'm talking about the different machine learning deployment options. These are not all the options related to the model deployment. If we can see that building a model is an easier task now, because we have definitely many automated platforms, so you can build your model on top of them. But when we talk about model deployment, it depends on the customer infrastructure environment. For some use cases, you can find the customer has Docker on top of their environment. Some customer you will not find. Some customer will give you an access to do some integration, whatever, installation for some tools on top of their environment, and some customer will say, no, the data privacy, security, and all of these constraints that came when we talk about model deployment in enterprise environment. First option, I will start, as you see, I have done like a mapping between the operating model phases, like design, data acquisition, modeling, deployment, consumption, versus the options that I have listed. Some of them, actually not all of them, we have started with on-premise. When we talk about on-premise, like coding the model in a Python stack and pushing this Python stack directly to the customer environment. Yeah, it's not the best option from software development, but to be honest, we have done this in around 5 use cases. Yeah, because the customer wanted to see a value from the use case. At the same time, we have a lot of constraints coming from the infrastructure assessment. You will find in the design phase, I have both public cloud like an option in all deployment option. Why? Because public cloud, it will give you the time and low cost, so you can do or build POCs on top of the sample data. Because here we are talking about the design phase. The design phase, we end up with a POC to show it to the customer before gaining their approval to proceed in the use case development. So, limitation in time, limitation in money, constraint related to infrastructure, and we have a needy customer is waiting something to be seen. Second option you will find, before moving to second option, which is containerized on-premise, I will give you that on-premise Python stack is not that bad, even if we send the code via email, because we have actually gained an experience from this journey, actually. But we have ended up that we have redeveloped again what we have done before to move from one option to another one. So the lesson learning came to us from this. It's better to start with a Docker, because Docker will do what's called isolation of the code. You can run different trained model. Why different trained model? Because in some model we have used TensorFlow as a framework. Another use case we have used Keras. Another use case we have used PyTorch. Okay, if we have developed all of this on top of Python stack, we have lost the value that came from Docker to isolate the different framework or application. If we mention that the trained model is an application at the end. So it was better to start in Dockerization or containerization of the models. To gain more value from other option, moving to the third option, we have done like mix between Kubernetes and Docker, and as I mentioned in the previous session, that Kubernetes is like a orchestrator, like a manager. So you can achieve what is called scalability on top of many Docker images, or Docker, containers to be more accurate. So mixing Kubernetes and Docker together will achieve what's called scalability, will give you what's called clustering mechanism, increase the high availability. All of this came from mixing Docker and Kubernetes. Another option was called hybrid cloud. Hybrid cloud, it's a mix between public cloud and private cloud. Private cloud like Pivotal Cloud Foundry. So you can do all of this on top Pivotal Cloud Foundry and push it to the production, the customer environment easily. And this will achieve another advantage like building CI/CD pipeline easily, having the DevOps by the book. So mixing all of this together, we have without operating model, we do not have a good approach to do this. Without people, we cannot achieve anything. To end up with having model productionization, this is what's called from my organization perspective, because this might not be the right one. It's called machine learning operationalization. As I mentioned before, building a model now is an easy task. All of us now can play the role of the data scientist, but not the best, you will not be the best data scientist. By the way, the data scientist is like a mindset. It's not something just to learn, by the way. So as I mentioned, building a model is an easier now task, but moving this model to the production environment is not that easy, still hard. So I will give you I will skip all of this, to be honest, just this one. This is like a simple architecture of the Docker. You have a container registry, contains all the images. And when we talk about Docker image, as mentioned by Dr. Ahmed, let me give you an example. You have your model, you want to have TensorFlow on top of Ubuntu operating system. So you try to find an image. In Docker Hub, for example, this image achieves this specs like the operating system is Ubuntu, the framework is TensorFlow, so you have the right image. You can grab it from the Docker registry to start to run a container on top of this, or like forking an instance from this image. So you'll find that architecture is very simple as shown. We have Docker registry, we have Docker what's called metadata. I call the Docker file like a metadata, the details that you put on top of in a file, so you can fork an image with specific requirement to run a container. This is simple steps. You need to find an image. First thing, you need to build your model on top of this image, having the Docker file, the metadata file that contains the steps. Then you will run a container from this image. This is like a simple architecture, high-level view of first option or second option that I mentioned, containerized on-premise environment. You will have the trained model exist on-premise storage, even if it's cloud-based storage, whatever. And the DevOps engineer will start to grab the trained model one by one and do containerization of this model. He or she will run the various steps to make the trained model ready in a container. And this container could be accessible via API, as mentioned before. It's like an endpoint, because the trained model might be a recommendation system. It might be a trained model giving some insight to the customer via dashboard or something like this. Whatever the endpoint will be, then this Docker container will be pushed to the production, and it will be accessible as seen in the right side, at the right side by the customer via IP or something like this. This view will achieve isolation of different trained model, will achieve that you are not restricted by the customer environment. Whatever the customer has installed in their environment, you do like separation or isolation between the trained model and the infrastructure environment. But you cannot achieve scalability. You cannot achieve this with this architecture. You need something like Kubernetes. As I mentioned before, Kubernetes is like an open source, do what's called orchestration to different containers. And by the way, Docker has another tool called Docker Swarm. But if we are going to compare Docker Swarm Kubernetes versus Kubernetes, you'll find, according to many people or many organizations, saying that Kubernetes is better from the performance and other stuff if we have comparing them together. Moving to the actual ultimate goal, when we talked about machine learning in my organization, our ultimate goal to consume public cloud. And to be honest, we have defined GCP as like the best solution, yeah, because we have a good tool stack when we talk about model development and so on. From the deployment, we have to, before that, it's not responsibility of the vendor, it's responsibility of the development or the one or the company that will do development of the model. The option of using public cloud for model deployment, as you see, you will find that the code, I mean here the trained model code will be exist in a repository. This repository could be GitLab, GitHub, and so on. and you have a Docker registry, or not Docker, sorry, it's container registry. It contains all the images that you have already prepared, and you will consume or use CI service, continuous integration service like Jenkins, might be Spinnaker with Canary, all of this open source tool, you can mix them together. And definitely you have model training pipeline and model serving. And this mapped with the machine learning pipeline that I have mentioned before. It's about model development, training, validation, testing, and so on. And we have a front-end panel could access, or you can administrate these services. And you will find an object storage to contain the trained model and the dataset. And by the way, you will find different platforms can list the trained models and can list the datasets itself. Mapping this with GCP services, you will find I have referred to Jenkins for CI, GitLab for code repository, Google registry for the container registry, Jenkins, as I mentioned. But in the middle, which is the orchestrator, the core of the machine learning pipeline, return back to the pipeline, data understanding, data exploratory, modeling. The two phases exist in the box at the middle, which contain Kubernetes engine on top of GCP, machine learning engine service on top of GCP, which is called now AI platform, Kubeflow, which has another, you can say, framework on top of GCP. You can navigate all of this service after finishing the day. And all of these services have a front-end panel. And for object storage, I have used GCS, which is Google Cloud Storage, to store all the trained model and the dataset. Yeah, the previous slide just gave a view about the deployment, but if you wanted to achieve a complete end-to-end flow, I mean, according to the machine learning pipeline, starting from the data understanding till the deployment, you can figure out different services on top of GCP. For example, if you have started at the beginning, you can host the data, the raw data, in a storage bucket. Storage bucket is like a terminology used on top of Google Cloud Service. And you have the code in a repository. You can do the data transformation using what is called Google Data Flow Service. And for data training, hyperparameter, all of this stuff that's related to the modeling, you can consume machine learning engine service on top of GCP. And for training the model, definitely we will use ML engine and other services. For deployment, you can definitely use ML engine again. This is a very simple view about end-to-end, machine learning-based software development. So, mapping what I have mentioned was a challenge that I listed here to say that Docker help. Yeah, first one is environment compatibility. You have tackled the environment compatibility because you didn't give it a focus. You will end up having the model code on top of Docker container, and you can have whatever the customer has, Linux operating system, or whatever. I have already containerized my requirement to run this model on top of Docker container. When we talk about different library requirement across the model, I have done Docker container for every required trained model with the required library, as I mentioned before, is it TensorFlow, PyTorch, and so on. Scalability that came from mixing Docker with Kubernetes, having reliability too, because we can consume CI/CD pipelines, so you can have a fully automated pipeline to manage your trained model. And portability, returning back to the image that I mentioned at the beginning, no, the business owner will not take the model in a bag, actually. They can find it in a Docker image. This is the answer. Now, the speed that came from using all of these open source tools together to achieve this. By finishing this slide, I have finished my presentation today. And thank you everyone for listening to me and bearing me, actually. You can follow us in Docker Meetup page or Cairo Women Machine Learning Data Science Or you can find me Google Developer Expert to follow our activity related to Docker. I will be there, so we can have any conversation or any discussion. Thank you again.